Hello, IBSL AI students. This is mock exam preparation, paper 2. Again, we're going to go to It's Learning, go to Plans, Exam Revision, and then down here, mock exam preparation. And looking at this last file, there's a video from paper 1 there. This one, the paper 2 preparation. So paper 2, we do not answer on the exam paper. This is a question paper. We answer on in an answer booklet, or for the mock, it's going to be just blank paper. Okay, so you're allowed to mark up this question booklet as much as you want, but it's not going to be graded and not considered in your grade. So you have to show your workings and answers on separate paper, being sure to identify clearly your answers by boxing them or underlining them. Okay, so first question, we have a cumulative frequency diagram here for a transportation company, 30 buses, and as we can see, the total number of buses goes up to 30. Okay. All right, so find the number of buses that traveled a distance between 15,000 and 20,000 kilometers. Okay, so first off, on the horizontal axis here, we can see that's 2,500. So it's actually 500 kilometers per division here on the horizontal axis. Okay, and then on the vertical axis, again, this is 22.5, 17.5. So I think it's a half a bus is what I wrote on my sticky note here that I can't seem to read. Okay, I wrote half a bus per division. Okay, again, I marked on the question paper, it doesn't matter. Okay, so 15,000 and 20,000. Okay, 15,000 go up from X, and I get 20 here, and I go to 20,000. Right here. And again, each division is half a bus, 27.5 plus a half is 28 buses. So for the workings, again, I get 28. All right, so each question goes on a new page. I'm going to use the outline format that's given. So my workings are just going to be 28 minus 28 buses for the first question. Okay, B. Use the cumulative frequency graph to find the median distance. Okay, so normally we would do n plus 1 divided by 2 to find the middle number, but because there are 30 buses, it's a pretty big number. We're just going to say that the middle number is basically 30 divided by 2, 15. Okay, so this is the halfway point. And we can see, actually, if I go across 15 buses, it gives me a nice intersection here, remembering, what was it, 500 per division. So I go from 12,500 here up to 13,500 here. So the 15th bus, basically 13,500 kilometers is what I get for the median distance. Okay, And then C, use the cumulative frequency to find the lower quartile. So again, the lower quartile is 25th percentile, 30 divided by 4, 7.5 buses. Okay, so 7.5 buses. Oh, nice. Comes right across here. Comes right down to 10,000 kilometers. Okay, so that's Q1. Q1. And then the next question is probably going to be, what is the upper quartile? Q3. Okay, so use a cumulative frequency to find the upper quartile. Again, I'm just going to do 3 times 7.5. I'm going to use 22 and a half buses for the upper quartile. 22 and a half come across here. Again, each division is 500 kilometers. So I went from 15,000 kilometers to 16,000 kilometers. Okay, so that's going to be Q3, our upper quartile. Okay. Question E. Write down the interquartile range. Well, there's actually a formula for this, but we know it's Q3 minus Q1. Topic 4, statistics. There it is, very first formula. $16,000 minus 10,000 equals 6,000 kilometers. F. Write down the percentage of buses that travel a distance greater than the upper quartile. Well, it's just a percentage. So, I mean, by definition, it's 25%. Find the number of buses that traveled a distance less than or equal to 12,000 kilometers. So I'm going to go to the question here. 12,000 kilometers. So that's one notch below 12,500. So right about here, each division's half a bus. So I make that out to be 11 buses. It is known that 8 buses travel more than m kilometers. So 8 buses, the top 8 buses, 23 and above, or 20 more than 22. So the 22nd bus is here. The 23rd bus is here, so I would say making a nice round number here, come down 500 per division, 16,000. So I'm supposed to write each answer on a new line for the marking, but I'm running out of room on my page on the iPad, and I had to actually go horizontally here, but not a game changer. Okay, so the last question again is a graph. We're going to need graph paper for that. I don't have any handy right now on the iPad, so it gives you the minimum, the maximum, and we know the Q1 median, Q3, and the upper. So we should be able to generate a box and whisker just I. Again, on graph paper, respecting the scale that they have, we're going to come up with something like that using the numbers that we have. Okay, next question. Okay, on a new page, we're going to write question 2, and we're going to answer these questions. Okay, looking for Pearson's here. What is the product moment correlation coefficient for this data? So I'm going to go to the TID4 here, and I'm going to put that data in list 1 and list 2. So go to just go to stat, edit, and again I have some information from old ones here. I'm just going to clear that information out. Do not delete the list. Go up to the top to clear. Okay. Now I put in list 1 for stand scores, list 2 for min-sun scores. So I put in those scores in list 1 and list 2 for stand and min-sun. Okay. Then I'm going to do calculate the Pearson's coefficient. I'm going to go back to stat, and I'm going to calculate linreg 4. And again, I want to make sure that I have stat diagnostics on here on the mode, or I won't get Pearson's. I won't get the R, Pearson's correlation coefficient. Okay, so stat calc for list 1, list 2, no frequency list here. I might want to store the equation for later if I want to, evaluate it, and I know I will, because there'll be a question on that. So I'm going to put it in yvars function, enter, calculate. Okay, and now they want to know the R value, and I get an R value of 0.909 for question 2A. So list 1 was Stan, list 2 was min-sun, and then I did stat calc linreg, and I get R approximately equals 0.909. Okay, so about a 91%. You could think of it that way, a correlation between their scores. Okay, interpret the relationship. Is 91% good, bad, in between? It's a relatively strong positive correlation, because again the R value is positive, not negative. and it gives us that slope. I don't know why I wrote that. That goes later. Okay, so Stan and Min Sun, strong positive correlation. C, write down the equation of the regression line. Well, it's on our calculator here. We have a gradient 1.14 for 3 significant figures. X plus B is our y-intercept, 3 significant figures, 0.578. Okay, so this describes a linear relationship between Stan and Min Sun scores. Again, we could do another kind of regression, see if we get a better result. But we're going to use that to estimate Min Sun's score, which is y, when Stan awards a perfect 10, which is x. So we're evaluating the function above at 10. So I get 11.4 plus 0.578. I think I get, in my head, I get 11.978, which is going to be in here under 10, value of 10 for x. What did I say? Okay, I was off. 11.981. Yeah, that's right. I just didn't add my 7, 8 and correctly. Okay, so this is again an approximation for what Min Sun would have. Well, that's a 12.0 to 3 significant figures. Okay, so that's what I wrote down on my answer sheet right here. Moving along here, state whether this estimate is reliable, justify your answer. I think we went beyond a perfect 10 there. Again, Min Sun scores were always lower than Stan's, were they not? I guess I could have looked here. No, because you see some are higher. Sorry, Min Sun scores are actually always higher than Stan's. So that's how we got above 10. We went beyond a perfect 10. So I would have to say that this result is unreliable for 2 reasons. We're beyond a perfect 10, and also we're outside of our data, which again is really what they want to see for the answer. It's outside of the values of x, so we can only interpolate, not extrapolate. Okay, so this is extrapolation, not really reliable for our model. Unreliable because it's extrapolation. Now F. And we're going to have to do a Spearman's now, a rank correlation coefficient. So we're going to copy this table into our answer booklet. So I did a crude copy of it here. I challenge you to do better. Again, they did it, gave us a little bit of help here by telling us what the top rank was and what the 8th rank was by the judges. Okay, so it's a good help. So again, the top score for Stan was G, the top score for Min Sun was G, and the bottom scores for both of them was B. So that's how we filled that in. Okay, so if that's the top score, well, let's look at him first. Stan, 7.5 Next score down is a second rank goes to competitor E. Okay, and then we go from 7.1 down to a three-way tie for sixth. Okay, so this is the third, fourth, and fifth ranked score all combined. So we have to do that 3 plus 4 plus 5 divided by 3. Again, it's the middle score, 3, 4, 5. That's 4. Okay, and that's why down here, this one's filled in with 4. So the fourth rank goes to F and D. So that's 4, 5, 6. After that comes 7, which is C. And then I think I lost count here. 3, 4, 5, sorry. It should have been sixth. 4, 4, 4, 3, 4, 5, 6, 7, 8. Okay, so that gives me, again, the ranking scores for Stan. And then we can see that Min Sun here, there looks like this is tie score on H, which it is. It's tied together with this 7.2 here. So this is 1. Here's 2. 3 is 7.8. So 4 and 5 tied. So that gives 4.5 for D. And then so on, 4 and 5, so 6. Sixth score was over here now this time. Sorry, here still. Sixth score, seventh score. Okay, so that'll give me the ranks for those guys, and I'm going to be able to put those into the same format that I did for Spearman's. Okay, so I put those ranks into the calculator. Here are the scores in the calculator in list 1 and list 2. Do a linear regression, on this. Do I care about storing the equation? I don't think so this time. We're just going to see how well the ranks correlate. Okay, so the ranks correlate at a 93.3% value for the Spearman's correlation. Okay, so we copied and completed the table. 2G is, again, list 1 are the ranks, Stan's ranks, and then list 2 are Min Sun's ranks, and then we did a Lin Reg on that. And I got R sub S is approximately equal to 0.933. Okay. H. Comment on the result for R sub S. Well, again, I think it's a very strong positive correlation. The commissioner believes Min Sung's score is too high, and so decreases his score for the top rank. It's exaggerated, knocks him down to 9.1. Well, how is that going to change Spearman? Does it change this rank right here? Is it still 9.1? still the best score? Well, indeed it is for min, sun, and in general for all of them. So no effect on the score. I'd say the rank is unchanged. Ranking is unchanged. No effect on the score. On the the Pearson Spearman's coefficient, correlation coefficient. So R sub S is unchanged. Rank or ranking remains the same. I don't really have any workings, so I don't have to box these answers. I think the examiners can figure that out when they grade my exam paper. Question 3 is a finance question. We're going to use the Tvm solver to do this. Easiest way to do that on the TID4. Brian decides to purchase a new car with a price 14,000 euros, but can't afford the full amount. So there are two options to finance a loan. Option 1, or A, excuse me, is a 6-year loan, 14% compounded quarterly. So quarterly is, again, 4 times per year for the TVM solver. Find the repayment for each quarter. So go to the TI-84. We want to go to the TVM Solver, which is an app. Finance, TVM Solver. And now this is what I want to show for my workings. I want to show the input to the TVM Solver and find my payment amount here is what they're asking for. And again, remember that the payments per year and quarterly is 4 times, and we make that at the end of each quarter. So 14,000, 4 quarters times how many years is it? 6. So I could just do 4 times 6 up here and get the number of payments. The interest rate is 14%. Whoops. Per annum. And then we're going to be financing an amount of 14,000 and going to solve for payment later. Future value 0. We want to pay off the entire loan on a quarterly basis. And when I do that, you should see that it defaults to there. So to solve for payment, we go to that box and we go alpha, green, solve. Okay, so now I see, again, this is money. So again, it's very clear here. It shows us that money, we have to give our answer to 2 decimal places, euros and cents. So solving, we get the payment value of 871.82. And again, we're going to round it up pretty much always because we want to pay off the entire loan here. Okay, so that's what I got to get those amounts in here and miss payment, but that's pretty much my my workings. Lousy euro symbol there. Okay, B, that's 3A, or excuse me, that's actually 3B. No, find the repayment each quarter. It was 3A. Find the total amount paid for the car. Okay, so the total amount is going to be our payment times the number of payments. So the number of payments we made, remember, was n, was 24. So I just have to take that answer and multiply it times 24, which is a little inconvenient that I just can't cut and paste that. Oh yeah, it's negative. It's out of our pocket. So that's the way it's supposed to be, a negative number. So I got to quit out of Tvm Solver and do that calculation manually. So how much did he pay for a 14,000 euro car? 20,923.68. No rounding off on the three significant figures, only round for 2 decimal places. And I showed my workings here. C. Find the interest paid on the loan. Well, it's the present value plus interest equals future value, or whatever the total of our payments. So we just have to subtract 14,000 from that amount, and we should have the interest. €6,923.68 is the interest paid. Okay, D. Finance option B is going to be monthly here. So again, I did the little sticky here that we're going to change CY and PY to 12. And again, I could have used this formula over here to figure out some of this stuff, but not really payments. It's you got to use the Tvm Solver unless you just want to find out what the future value was, the question above. Okay, to get the total. Okay. So let's stick with the Tvm Solver on these questions. Again, try and show our calculator input. Again, no room here on the question paper. I got to put this down on in my answer booklet. So 10% deposit. Okay, so 10% deposit. What is 10% of 14,000? That is the total value of the loan. That makes it 1,400. So the total amount of the loan is actually going to be 14,000 minus 1,400. Okay, so that gives me 12,600 for the amount of the loan. All right, so now this is what I'm going to put into the Tvm Solver for the PV, okay? And I'm going to be making payments of 250 on the Tvm Solver, okay? And then I'm going to solve for interest rate. So again, it was monthly, 6 times 12 for 6 years. 10% down makes it 12,600 being borrowed. And then, whoops, my calculator quit on me. Be right back. So this is going to be my input. The payment was $250, 12 times a year, 72 payments. And they want us to solve for the interest rate. So we're going to go up to here and use the green button. Whoops, I need a sign change. Interesting, I learned something there. So where is the money out of our pocket? It's here. So let's make that negative 250 so that I'm subtracting from the amount borrowed. So it looks like about 12.6% interest. But they wanted 2 decimal places, didn't they? Even though this isn't technically money. So I'm going to put 12.56% for my answer. And again, you can check the mark scheme and see if that's what they did. Okay, so yeah, how much did he borrow there on option B? We had the total amount paid for option A. So let's take a look at these totals and see which is perhaps the most favorable option for borrowing the money for the car, presuming that you have the down payment for that, of course. All right, so I'm going to do 12,600. Oh no, wait, it's still 14,000 because again, and then I'm going to do 72 times 250 per month. Okay, so when I did that calculation, I didn't do it yet. 14,000 plus 72 times 250 is, my gosh, 18,000 as I recall. Yeah, he's paying 32,000 for the car that way. Brian. Okay, so I get 32,000 there, and the previous option was what do we calculate up there for? I can't drag stuff anymore. 20,000. So definitely, option A is the cheapest option, and that's our justification. It's less expensive. All right, and then finally, we got a depreciation question here to answer. You drive the car out a lot, it depreciates 25%. As soon as you get out of there, it's going to depreciate 25% every year. So 100% minus 25% is 75%. So our ratio is going to be 0.75 between adjacent years. So I take the 14,000 and I multiply it times 0.75 to the sixth power. Okay, and that's how I'm going to get my answer here for the depreciation. 6 years. So the car is only worth $24.91 and 70. I got to round that up. All right. And question 4, we're going to be doing chi-squared here. You can see that this is a 2 by 3 matrix, 2 rows, 3 columns. The significance level is 10%, and we're given the critical value here once we can find the chi-squared statistic. Okay, state the null hypothesis for this test. Again, the null hypothesis basically is that the 2 variables are independent. So how would I say that? I would say that the chosen meal, and the customer's age, okay, are independent. Okay, doesn't matter which way I would do that, but I don't think age is a function of meal. I think meal is a function of age, so I would write it that way. So H not is choice of meal or meal choice is independent, I like that word, of age. Okay, so there I have my 2 variables and the word independent in between there. All right, write down the number of degrees of freedom, and then we're going to show the expected number. So this is one of the formulae that's not in on the formula booklet for this. We don't have anything for chi-squared. So we got to know that the degrees of freedom is rows minus 1 times columns minus 1 is the formula. So there were 2 rows and 3 columns, not clowns, columns. Calculator quit again. So 2 minus 1 times 3 minus 1, 1 times 2 is 2 for the degrees of freedom. Okay, again, the expected frequency for children who chose shrimp. So we're in this box right here. In this box right here, we're going to do the row total times the column total divided by the total. Again, the expected frequency is not a formula in the formula booklet. We have to just know that this is based on proportions, probability. So row total times column total divided by the total. 69 times 67 divided by 150. I lost my bar here for pausing anyway. I'm not going to be able to pause. We'll just roll through with it. And when I did that calculation, I got about, you got to show that it's about 31. Well, show that. Okay, so I know the answer is 31. I don't need to use my calculator. Okay, D. Write down the chi-squared statistic. I'm going to need the calculator here. So if it'll open back up for me, we're going to go into the matrix. Good movie. And we're going to input our values for rows and columns, and then we'll be able to calculate the chi-squared statistic. We'll also see the degrees of freedom and the expected frequencies there that we've already calculated by hand. And we'll get the p-value, and we're going to be able to compare the chi-squared statistic to the critical value and the p-value to the significance level. So matrix is here, second matrix, and I want to edit this matrix, and I want to make it 2 by 3, 2 rows, 3 columns, and you see now it matches my question paper over here, and I can input those values to the matrix. Okay, so that's my matrix done. I'm going to go out of this again. I don't like to stay there. And I'm going to look at the chi-squared test for independence. Okay, so go to stat, calc, tests. And the chi-squared test is hidden in the bottom. And my observed matrix is what I just filled in. It will fill in the expected matrix for me and show me that the kids were expected to have about 21, and give me my chi-squared value and my p-value. Degrees of freedom is 2, as we calculated before. So write down chi-squared 2.66 and p-value 0.265. And again, I want to show that I used the TI-84 and did it that way. But I'm not going to take the time for that right now on my workings. So write down the chi-squared p-value. State the conclusion for this test. Okay, so is this a high chi-squared value? No, it's low. It's the calculated is lower than the critical. Is it a high p? Yes, the p-value is greater than the significance level, 0.1. So in both cases, chi-squared is greater than, less than chi-squared critical value, and the p-value is greater than the significance level. This means accept the null hypothesis. So the choice of meal is independent of age. Okay, accept null hypothesis based on that data. Okay, then we have some probability questions. Calculate the probability that the customer is an adult. Well, how many adults? 81 over 150. Okay, calculate the probability that the customer is an adult or that the customer chose shrimp. Okay, that's a little bit more difficult perhaps. What what do we say the first answer was? 81 over 150, right? And I can simplify that or give it as percent. That's 27 over 50. I like 81 over 150, and you'll see why in a second. Okay, so H. This word or means that I'm going to be adding, or that the customer chose shrimp. Okay, so we know there are 81 adults, but I can't count this 32 twice here for the shrimp. Okay, so I'm going to do 81 over 150 plus the probability of shrimp here, and I can't get an answer of more than 150. If I did that, if I had that in there twice, I would have a probability of greater than 1. So I got to take that 32 away from this 67, which makes it 35. So 81 plus 35, 116 divided by 150. I mean, you can divide it by 2. It doesn't really matter. Equivalent answers are acceptable. You could give it as percentage or a decimal. Is there a question I? Given that a customer is a child, calculate that they chose pasta or fish. So again, we're going to be adding the pasta and fish together for the children. So given 69 is the denominator, pasta or fish. So I add pasta and fish together. 24 plus 25 is 49. 49 over 69 kids is the probability of that. Okay. Last question is a calculus question. So again, we're going to be doing some optimization here. We're going to have to do some a little bit of geometry here, three-dimensional geometry, to get this equation down to one variable. Okay, so we have a speaker, Bluetooth speaker, cylinder, and 2 hemispheres. For me, write down an expression for the volume of the speaker in terms of the length of the cylinder and the radius of the 2 hemispherical ends. Okay, so question 5. A, it's a sphere because it's two hemispheres. The sphere plus a cylinder is the volume. Okay, so the volume is going to be a sphere in our formula booklet. Is it prior knowledge? Prior learning? No, because it's three-dimensional. So I got to go to topic 3. And here's the volume of a sphere. 4/3 pi r cubed plus the volume of a cylinder, which was in the prior knowledge, is pi r squared times L. Again, it's a prism. It's the cross section times the length of the third dimension right here. Okay, so there's my equation for A. R, L, and H, or pi r and H. Actually, we made HL. Okay, so now B, surface area. Okay, so this is not an expression. Actually, they want an expression. I wrote an equation, but or a function. Now they want an equation. 300 equals the surface area. Okay, so again, the surface area of a sphere is 4 pi r squared in the formula booklet. And the surface area, the curved surface of a again, is what we did before, was 2 pi RL when we did that on paper 1. Surface area of a sphere, 4 pi r squared, and then it's going to be 2 pi RL for the surface area of a cone. Right there. Okay, so there's A and B. We have our two equations, two unknowns, R and L. We're going to have to do some substitution here to get it down to one variable so that I can do some differential calculus on this. Okay, so C, they're going to ask us to substitute for one variable. So they want us to find L so that we can do dv dr, find the derivative with respect to r. So L is equal to that, is it? Take the equation above, subtract 300 minus 4 pi r squared is equal to 2 pi RL. L is going to be equal to 300 minus 4 pi r squared divided by 2 pi r. Okay, and again, you can see that they just divided everything by 2 here to cancel it out. So there's my basic linear algebra there that they want us to rearrange the equation solve for the equation in terms of r. Okay, so now I'm going to take that L and I'm going to put it into the volume formula that I had up above, which is gone now. Okay, so again, the volume formula was, again, the sphere plus a cone. So volume is 4 pi r cubed, 4/3 pi r cubed, the sphere, plus the cone, pi r squared. And then instead of L, I'm going to substitute in this expression for L. All right, and then I got some pi's in the numerator and r's in the numerator and denominator here, so I'm just going to cancel out those pi's and then one of these r's. Okay, and then it's okay as I left it. So now the volume is going to be equal to 4/3 pi r cubed plus 150 times r. That still distributes there. And then minus 2 pi r, the r has to distribute, cubed, okay? And then these two r cubed terms are going to combine. That's actually 6 over 3. So I'm going to have 150r, and then I'm going to have 4 over 3 pi r cubed minus 6 over 3 pi r cubed. So that's going to give me 150r minus 2 over 3 pi r cubed. Okay, so now V is in terms of r only, which is handy for doing our finding our derivative. Find the VDR. So again, I showed all this above. I didn't even have to derive this equation. I could have just substituted it and gotten in there a little bit more quickly. So the power rule to find dVdr. Topic 5, calculus. And it's the first rule there. Not doing any integration on this exam, only in differentiation. There's the power rule. We take the n down front, the exponent down front, we multiply. Then we take away 1 from the exponent, okay? So question G, question D. Find dVdr. I don't know how I messed up my numbering there. So dVdr is reduce the power, take the power down front, and then reduce it by 1. Okay, so this first one here actually has a power of 1. Okay, so I take that 1 down front, and then I take it 1 away from 1, I get r to the 0, and then anything but 0 to the 0 power, it's undefined, is going to be 1. So our derivative is just going to be 150. Okay, that's the gradient of that, the rate of change of that part of the equation. Okay, so now this equation, I'm going to take the 3 down front. I'm going to take the 3 down front, and then I'm going to take away 1 from 3. So 3 times 2 over 3 is going to be 2. And then left with r squared. Okay, so this is dVdr, the rate of change of volume with respect to radius. All right, now we're going to do some optimization here. The quality of sound will improve as V increases, so we want to find the maximum. So the maximum is when dVdr is equal to 0. So we're just going to solve that equation for 0. Okay, and then when I solve that equation, divide everything by 2, I think I get the square root of 75 over pi. Okay, not going to show you how to do the algebra. Go to a new page. If I'm going to do a new page here, I need to, again, write the question number on there and my name on every page. Okay, so this is 5x. F, find the length of the cylinder for which V is a maximum. So the length of the cylinder we were given up here, 5F. length of the cylinder is just going to be 150 minus 2 pi times that 75, square root of 75 over pi, right? Squared divided by pi r. I think that's the way I want to evaluate it. Oh, we knew that r was square root of 75 over pi, of course. Okay, so that's what I'm going to put into my calculator and evaluate. And then the same thing for the volume, 5G. I want to do my volume formula, putting in 70 square root of 75 over pi for the radius. Okay, and then make sure that I cube it here. This is what I made a mistake on when I was doing my workings. That's cubed divided by 3. So now I get my volume numbers. Again, I'll leave the calculator work up to you. And finally, H is going to be find the dimensions of the speaker. So, well, we just found them. Okay, we know the radius is the square root of 75 over pi. You can round that to 3 significant figures if you want so that people understand what that is. It's going to be about 5 centimeters for the radius, I think. And then the length, we're going to use what we had up above for question F, the value that we got from question F. So we'll have the shape of the speaker is as given, and it's actually dimensions they should be asking for. Okay. And that concludes paper 2. A lot of longer questions, more points for each question, answering in a separate booklet, all those kind of criteria there.